Okay. All right, man. So, sure you can see the screen. You know how to lab, right? I know, a lot of folks studying for multiple things. Whether it be Cisco, whether it be, Windows stuff, Linux stuff, or what have you. I know the common thing is, hey, can I? The common question from folks, and I think I had this question in the past as well, is, um, where can I get labs at? Where can I do this? Where can I do that? And so, you know, typically, my journey to becoming a person that creates my own labs, my journey was my inspiration was, hey, I'm, you know, all these things, images and programs like Eve and GNS3, they're out there for free. You can download them, what have you. But how am I going to go ahead and create an environment, right? So that I can test a concept or a theory, right? If I'm testing spanning tree, okay, what's the lab for that, right? What's the purpose of it, right? And typically, back in the day, I used to just always think, damn, I need somebody to just make a lab for me. When in essence, I could have used my imagination, and use what was in front of me. Typically, all the books, the CCNA, they'll give you a diagram, right, explaining, hey, spanning tree, right? Redundant links, within a topology, right? So, okay, redundant links within the topology. Let me just connect 3 switches or 2 switches together. Boom, that's a lab right there showing spanning tree, right? Or Jose, for example, for you, oh, let me test HSRP. Perfect. Let me do 2 multi-layer switches that's running layer 3, right? That's connected down or trunked down to, some layer 2 switches, for all VLANs and what have you, right? Boom, and connect to some PCs. Boom, that's a lab, right? And so, using your imagination there, right? Using the examples that you have in the book, that's one way to tackle it and say, hey, you know what? I create my own labs. It's right there. Another technique that I use is, before we jumped into tech, right? Before we started chasing down the line of hey, I want to get this cert, I want to get that cert. You guys worked in different places before, I want to assume, or seen different places of businesses before, like a grocery store, what have you. All these places, they require internet access. So if right? Okay, I've been in an office building before. I worked doing something not related to tech, but it had, a whole bunch of cubicles that had a wired port, and that wired port I know went all the way back to a switch. Oh, I can go ahead and just create, an environment like I did whenever I was working at a call center, not doing tech stuff, but I know the building layout that it needed a port on a switch for every cubicle, right? And that's how you can go ahead and, use your ingenuity and say, oh, dude, I can create a lab here based on my imagination, or, based on my past experience. So then you can use your imagination to go ahead and create all these labs. So in turn, as long as you read about a, certain technology, spanning tree, OSPF, et cetera, you can go ahead and start creating your own topologies to the point to where all you're doing now is just trying to, get proof of concept for yourself, meaning that you're trying to just understand the technology for yourself. Does that make sense?
Yes, sir. Makes sense.
See, folks are muted. Cool. Claude, you want to add, some nuggets there? I know me and you, we connected in the past talking about how we learned spanning tree just by going to, Starbucks or going out somewhere and just taking no laptop and just taking a pen and piece of paper with us and just writing it out, like drawing and stuff.
So, it's like you said, you go to these different places somewhere that got internet access. Even before going there, most of you have internet access at the house. But what happens is a lot of people are somewhat reluctant to dig into their ISP router or modem. Your ISP modem has an inner has a web-based GUI that you can actually interface with to actually make changes to your router. You know, uh, your home network is just waiting for you to explore it. You know, and that's where you start with first. You know, you understand uh, your WAN connections. You get to understand your LAN connections on the wired side, and most of these modems nowadays in the house actually do Wi-Fi as well. Where back in the day, it was
Mhm.
just the hard wire, and you had to go to Walmart or Target somewhere and buy a separate wireless router to connect to that. So you don't gotta do that these days because it's all integrated. And you know, you can actually sit and play with your home network and just your PC and do a lot of things and understand a lot of things. You can run Wireshark on your home PC and take captures just on the traffic that you think is not coming through your home. But when you look at Wireshark, Wireshark's going to paint a different picture, you know, and you'll look at it. And the funny thing is, you'll sit there and say, nobody's in the house using internet, but Wireshark is
Mhm.
going crazy. Wireshark
Mhm.
is just running packet after packet and all kinds of stuff. You'll see strange IP addresses. You know, that's your modem, that's your computer talking with, you know, servers on the outside world, you know,
Right.
and you can
Right.
stop that stuff and start analyzing those packets and understand what's going on, what's being said back and forth. If you can find a TCP handshake in there somewhere, you know, you can look at that and find your sync ACK and your ACK, you know,
Right.
and you can
Right.
analyze those packets right at the house. And
Because
that is a lab just in itself, believe it or not. May not seem like a
exactly.
lot, but it's a lab in itself.
Exactly. Exactly. And Claude, I love how you said that, to where you were saying, dude, you could see how, pull up Wireshark and see what's flowing.
Yeah.
Guys, that's a lab in itself. You guys have all of this text, the books that you're buying or what have you. They tell you the theory. They tell you the theory. You see all this traffic, boom. It's Wireshark is going to help you connect the theory to what's actually happening. Then you're going to say, oh, like Claude was saying, oh, a TCP handshake. Wow, I tried to go to Google.com, had to do a TCP handshake. Boom. All right, got the send at cool. We go ahead and start that session, and TCP windowing and stuff like that. Oh, that's how that works, right? That's a lab in itself. It doesn't have to be anything extravagant. I know, and Claude, thank you for sharing that. Claude is Claude and other folks have mentored me a lot, and did some myth busting, with whenever I was rising up in the ranks for like CCNP and stuff like that. Do not let these LinkedIn topologies that you see from people intimidate you. Because I guarantee you, these folks don't even know what they're doing. They just pulled it from somewhere else, right? They just pulled it from somewhere else. When all essence, right? All essence, they probably have 15 or 16 switches and routers. Dude, typically there's some, in a production environment, yeah, physically you'll have two switches. Dude, you got them, you got some type of virtual chassis set up to where they're looked at as one. So like, for example, like Claude was saying, it's, logically, it's one switch, one router. Right? So they don't even know what they're doing. They're just copying what somebody else did. As long as you guys know the technology, all you're trying to do is just get the concept. That's it. That's it. Any other questions, folks? Alejandro, I see you joined up. What's up, man?
Hey, how you guys doing? Doing good.
Hey,
What's
man.
up?
Pretty good. Pretty good,
All
man.
right.
Jose, Harris, Aaron, any questions, bro?
Oh no, I'm good. Thank you, bro.
Okay. Cool.
I'm good. I'm good
I'm
too.
good,
I
man.
think what you said, it was really good. I mean, I feel like the topology that you want to lab, it doesn't have to, like a fancy big one, LinkedIn topology. Just has just a
Mhm.
couple routers, a couple switches, and focus on something, I guess, and go from there.
It, brother. That is typically it. You know. So
Let
like I
me
said, I wanted to keep
let,
this
let, let me share
keep this
something. You
short.
mind if I share the screen real quick?
Oh yeah, cool. Go ahead. Let me go ahead and allow share for all participants. Go ahead, boss. You
All
got it.
right, let me see here. All right, I'm gonna do a share app. Let me see, Microsoft Word, share. Okay, you probably see a Visio diagram, right? On the Word doc.
Yes,
Yeah,
sir.
I see it.
Okay, so this is how simple this is for me. My typical labs look like this, and there's going to be something in common when you see this. All right. So down here you see router file BGP filter, right? That's a specific lab that I've saved on my routers. Okay. Let me go down to the next one here. I got another lab here, BGP again. All right. This is me working with iBGP. Okay. This one here, this is a DMVPN. Okay. I'm implementing phase 3 because all these got router names on them. So there's config saved on all these routers to pull this all together. Okay. Here's another one. This is me doing dual head in DMVPN. All right. Now, I don't know if you picked up, but these topologies share one thing in common. This here's my EIGRP baseball topology. Did you pick up what these different labs had in common? Anybody pick up on it? Let me scroll back to it again.
Naming convention.
No, not naming convention.
It's only 4. I mean,
Exactly.
it's not like a huge. It's not 100
Exactly.
switches on the
Exactly.
route. It's small.
Exactly. So everything, this is where it started off for me here, this EIGRP baseball. So if you picture home base, first base, second base, third base, right? And then you scroll, I'm gonna scroll up and you kind of see the same concept again, right? With a different lab, right? Okay, I may throw a switch in. That's what that J4 thing is in here, ESW. That's a little switch in there, no problem. This one here, still 4 routers, right? Go up here. You still see that baseball diamond in here, right? Just the connections are slightly different, but it's still that baseball diamond shape, right? Come up here. You still see that baseball diamond, the 4 routers. I got a couple switches thrown in there, and believe it or not, those 4 routers stay in that configuration, that little, what I call that baseball shape, baseball diamond shape. I can do OSPF. I can do BGP, eBGP, iBGP. I can do eGRIP. I can take them 4 routers and do multi-area OSPF. Okay. I can do RIP. So you see where I'm getting at as far as the topologies. They don't have to be anything fancy. Those that got packet tracer, it don't have to be anything fancy. It can be the same thing. I can put DHCP. I can put DHCP in that baseball topology. I can set up, all kinds of, if I need to, I can throw a switch, because in this lab, I got, 3 3750s and I got 3 2950s. I can drop a switch in the back of them without in that topology somewhere. And each one of those routers actually has a switch module, which gives me an additional layer 2 switch. Okay. So again, my topologies, they're not fancy. They're not fancy at all. My topologies are extremely simple. And when I'm ready to change, I can be pounding hard 1 month on BGP. When I'm all said and done, I'll go to my flash or my routers, and I'll want to do some EIGRP stuff. I'll go ahead and load the config for that router, and then I'll go to the back of the routers and make the connections that they're supposed to be made. And 9 times out of 10, it's the same connections, but I'll just verify them, you know. But when the router comes back up, it comes back up under a different, like I think it was Griff that said, a different file name, a different naming convention, which has a totally separate, different, completely different config on it. And it might be utilizing a totally different protocol. So the thing is, keeping it simple, take the thinking out of, you know, the topology, because what you really want to focus on is the actual work that's involved with whatever topic that you're trying to go over. The topology should be your simplest. That should be the simplest thing right there, you know. Now, I'm not saying that you just got to create one topology and save it, or you could. You can put the topology together. You got packet tracer, you know, put 9, 10 nodes in there together, save it, and just use that same topology over and over. But I'm gonna tell you this: the protocol is gonna work the same. They're gonna work the same, you know.
Yeah.
And like I
Yeah,
said,
that's good.
you don't need, you know, 40, 50 nodes. It looks pretty, you know, it looks real, you know, like you're really doing something. But like Dave said, you're just trying to get an understanding of proof of concept. You know, I can go to this topology right here, this BGP filter, and I can just work on some stuff between this here 10 network, this J2 router and this J4 router is sitting up at the very top. Okay.
Mhm.
And I can put, like you see these loopbacks here on the very top. I could put some loopbacks up there to simulate some LAN networks or something. I could do some ACL blocking. It's limitless. I'm telling you, it's limitless.
Yep.
But
100%.
don't let the, you know, how should I configure it? How should I put this together? No, you just make sure they connected. That's all you got to do. Just make sure they
That's it.
connected.
That's it, brother. And you know, and it comes with knowing the fundamentals, guys.
Yeah.
You know, it's just all about knowing the fundamentals. If you know, right, the 3 basic functions, you know, for me, you know, my key area is layer 2, right? You know, switches and stuff like that, right? If you know, right, if you know for a fact, oh, cool, you know, main purposes of a switch is, you know, 3 major functions of a switch is to, you know, learn MAC addresses, you know, based on the source frame, you know, forward MAC addresses based on the destination address, right? And, you know, prevent loops using spanning tree, right? You knowing all those things, right? You can keep it simple. Damn, okay, what am I trying to test out? Okay, I'm trying to test out multicast. Perfect. Okay, I can create a simple topology. It doesn't have to be too crazy, right? And I wanted to show this to you guys, right? Just as an example, right? To support my my argument earlier, right? You know, as far as, you know, you guys can create topologies based on what you see on the book, right? You're gonna get the theory, right, in the book, right? This section is telling me about MAC addresses and multiple switches, right? Dude, topology's right here for you. Get right into packet tracing,
Yep,
right?
that's a lab.
And
That's a
just,
lab right there. Yep.
dude, go ahead, bow, boom. And let's get some PCs up in here, just like they have it. 1, 2, 3, 4, right? And I'll go ahead and just go crazy and just start doing some interconnections, right? And just start connecting everybody, right? You know, 100 meg link, you know, we'll talk about that later, but, you know, connecting it, right? Connecting it all together. And once I have everything connected, oh no, oversubscription, let's go ahead into that. But yeah, let's go ahead and connect them together, right? Got them connected. Boom. Right? What does that look like? Exactly what we have there. exactly what we have there. But again, MAC address table and multiple switches. So this section, right, whatever I'm reading, and again, this is an example, is trying to teach me about how MAC address tables work and working with multiple switches. Let's say I move forward to something more advanced within switching, like again, like multicast, like, you know, investigating unknown unicast frames, right? Investigating all that, right? I can use the same thing. As long as I know the fundamentals. I can use the same topology. I don't have to go too crazy. I don't have to have 7,000 routers to get the concept of just one technology. It applies everywhere, no matter how big or small your topology is. Does that make sense?
Yes, sir. Makes sense.
Cool. 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 Guys, any questions? IB, what's going on? See, you just joined up.
Chilling, man, chilling, eating my chicken nuggets.
So goofy. So goofy. So goofy. So goofy. Hey, brother, by the way, folks, I do want to give a huge shout out. And again, feel free to, I don't want to volunteer his services, but reach out to IB. He did a great job doing a packet analysis on the packet capture that I provided to you guys last week as a challenge. So yeah, one of the key things you'll have to do as an engineer. So IB, awesome stuff. Guys, definitely clap it up for him, give him some kudos. And that's one piece of becoming an engineer, right? It's not just about, oh, nice, I get to work on switches and routers. Nah, brother, you're gonna have to analyze stuff. So, you know, again, part of, you know, labbing and bringing it all together. Any questions, guys? Again, the purpose of this talk, it's just this meeting tonight. It's a short talk. You know, we're just, you know, tackling the topic of, you know, how to lab and just how to use, you know, what you have already in front of you, your creativity to go ahead and start building your own labs and not having to rely on, you know, what you see on LinkedIn and just trying to pay people to just give you labs. You can create labs on your own using Packet Tracer, GNS3, what have you, all for free. The goal is just to get a proof of concept. Fabiano, what's going on? I see you just joined.
Hey,
What's up, man? Long time.
I'm late.
Oh, it's all good. It's all good. We're recording this, so yeah, you can definitely listen up. Again, the topic we're talking about is just how to lab and giving everybody, you know, just tips and tricks on how to, you know, create you guys' own labs and not having to rely on somebody else's labs to get the proof of concept.
Good stuff.
Yeah.
Yeah, just remember, guys, it's you're limited by your imagination. That's it. That's it,
guys. That's it, guys. Any questions, guys? Again, this is real quick. We just want to, you know, address this and just provide any, you know, questions that you may or may not have had. Alejandro, I see you unmuted. You got a question, Jose?
No, I'm good. I'm good.
Okay.
I just wanted to let you know that I tried what you told me for the HSRP problem, and I got it to work.
And that worked?
Yes, sir.
Nice. There we go. There we
Yeah,
go.
thank you.
All right, folks. Well, I'll go ahead and end it tomorrow night. We do have our lab project, so feel free to jump in. Again, this is the lab project purpose is to
I think
help you guys.
I think Alejandro got something.
Oh, Alejandro, you got something?
Sorry, yeah, I was getting a phone call at the same. My bad. Yeah, just real quick.
No,
I appreciate you guys you know, I just jumped on. I'm actually at work right now, but it's all good. I know there's this CCNA gauntlet, and was it like a couple weeks ago you put out the requirements. So I just want to say thanks for keeping it simple, because I started out with this like building number 1 ether channel, you know, 7 switch, like layer 3 switches, routers. I'm thinking like, where do I even start? So,
well, you done confuse yourself. Like, damn, what am I going to do?
So I wrote this all down, like all the VLANs. Okay, I'm gonna have 2 VLANs, management VLAN. So it's all written down on paper. So okay, everything's organized that way. But then on my packet tracer, I'm like, you know what? I took one switch, just not even a part of the topology, and I just started writing. Okay, this is gonna be my base configuration. and then I'm gonna just copy and paste this over all the switches,
Mhm.
and then I'll start getting I guess more specialized in
Fine
each-
tuning it. Yeah.
Exactly. So
Yeah.
it's like I was looking at this. I'm looking at this crazy topology, but here I am messing with just one layer 2 switch, trying to just get a base config down.
Right.
So
Right.
start simple. Yeah, start simple, like you guys said. Start simple.
Stuff, brother. Good stuff. Absolutely. Couldn't agree more.
And
Couldn't agree more. All right, folks. With that being said, like I said, to reiterate what I was saying earlier, tomorrow night we have our lab project. Again, the purpose of the lab project, where everything that you're learning on the CCNA, CCNP, and I know some of you, the CCIE, all of this is tackled within the lab project. So no matter what level you are, if you haven't even taken a Cisco exam or networking exam at all, you can learn all of it here. Okay, so tomorrow night, 8 p.m. Eastern Standard Time, feel free to jump in. And of course, that meeting information is always dropped down an hour before or 30 minutes before. That being said, I'll go ahead and close it up. Folks, thanks again for joining.
Have a good
And
night.
I'll see you tomorrow.
good night, everyone.
Have a good night, y'all.
Take care now. Take care.
Later, folks.
Bye.